Hello Sackville, hello Year 11. I hope all is going really well for you. Welcome. I hope your mocks went okay a couple of weeks ago. So today, we've got a topic today which students actually found quite hard. You did, I think, a similar mock to my students where I teach, and networks are tricky. Networks, protocols, and layers. It's a really challenging topic, okay? So let's think now about how we can manage to actually gain as many marks in this topic as possible. Right, let's have a look. So networks and topologies, and I'm going to do this in two halves. I'm going to do networks and topologies today, and I'll do protocols and layers next time because this is a highly technical topic. Types of networks. Let's start there. So first of all, from this, the key thing is they're going to start by asking you about what is a network? Does this student know what a network actually is? So they might ask you about the advantages and disadvantages of a network, and they will go on and look at different types of networks in a couple of minutes. So first of all, the first thing you're going to start with is the advantage of having a network is, let's go back even further. What is a network? A network is two or more computers connected together to share information. They may ask you that, but probably not. They're going to assume that knowledge, but that is what a network is. Two or more computers connected together to share information. And of course, these networks could be wired or wireless or both. And we'll explore that later on over the course of this week and next week. So they'll then want to know, do you understand the benefits and the drawbacks of using networks? So, advantages. Let's have a look at these first of all. You can use this word down here on the bottom left, the word share, okay? And if you start with the word share, you can then talk about sharing, and let's go to this guy. You can talk about sharing files, you can talk about sharing internet connections, and you can also talk about sharing peripheral devices. So things like, there's three possible marks there, okay? So sharing files, a Word document for example, sharing an internet connection with other users, and sharing devices such as printers. So those are three really key benefits. The other two there I would totally ignore because they're not that useful. Disadvantages is that, and this reliance on network resources means that if you are reliant on network resources and the network goes down, then you can't do anything at all. We had a case in school 2 years ago where the network went down for a day, and it was, and I'm not a very nice person, it was highly amusing to see teachers really struggling without having the networks. They couldn't use PowerPoint. I mean, what would teachers do without PowerPoint? I mean, I'm old enough that when I started teaching, you weren't teaching with PowerPoint, you were getting up and doing it on a chalkboard, and then you were doing it on a whiteboard. So reliance on network resources. If you are reliant, your business is reliant on a network, and the network goes down, you've got problems because you can't do anything. So that's what that means. The next thing is that the hardware is really, really expensive. Servers are super pricey. Switches are really expensive. And you're talking tens, sometimes hundreds, but in a school context, 50, 60, 70, 80, 90,000 pounds for a server. That's what you've got to spend these days if you want to have a server that's a really good one. And normally you're buying two. So you're not reliant on network resources, because if one server goes down, you haven't got a second one, a backup server if you like, you could have problems. Some schools can't afford two servers. The other thing is you've got the risk of viruses and hacking. If someone can get into your network, into your server, that's going to cause huge amounts of problems. I'll stop saying server in a minute without explaining what a server is, but there we are. The last thing that you can talk about with a disadvantage is that you need specialist staff to run networks. You can't just turn up and manage a network or set a network up. You do actually need to know what you're doing. And of course you have to take the right qualifications, usually sort of Microsoft, Cisco, those sorts of companies, in order to be able to run a server, okay? So those are the pros and the cons of networking. So first of all, what is a network? Two or more computers joined together to share information. And secondly, you've got the pros and the cons. On the pros, talk about sharing. On the cons, you can talk about any of these guys down there on the right-hand side. So that is what a networking is all about. The next stage, so that's going to be the low-hanging fruit. The course that you're doing, you will know, is called OCR J277 9 to 1. They need to have questions that are for people who may achieve a grade 1, as well as questions that are going to test those who want to achieve grade 9. Two of you in, please do say hello. Or not, but if you say hello, it's nice. There's no requirement, no stress. So we're going to look at two different types of networks, a local area network and a wide area network. And again, it is unusual if they don't ask you to define these in an exam. This is a 2 out of every 3 exams type question, okay? So we'll go through what these are now. So a local area network, which is a connection of computers and devices, and this here, by the way, is just there for your information, because this word, node, they may use in the exam, so make sure you can recognise it. And a node is any device on a network. So it could be a mobile phone, it could be a laptop, it could be a watch, it could be anything. Any hardware that connects to a network is called a node. Just handy to know, because that word can throw you if you're not familiar with it. So in a local area network, the hardware is usually owned by the individual organisations. Interestingly, I reckon when they update the specification, they might change this, because at school, in the school that I work, I reckon, was it a year ago? Rather than owning the computers the staff have, they've actually taken out leases on a bunch of laptops. Not sure whether they quite worked through how long the batteries would last, but that's another story altogether. So in that case, in the case of schools, let's keep it simple. Schools usually own all of their hardware. They own the servers, they own the switches, they own the computers, they own the cables, so schools buy them. So that's what differentiates a local area network from a wide area network, is that hardware is usually owned by the individual organisation. Usually, a local area network is confined to one site. They can be more, but that's why the word usually I've used, is that usually that's the case. And also, this is something which, when I mark these assessments from exams, and it asks people to define a LAN, some of the weird, strange answers that I get. People will say, it's an area over a local area. And you think, why do people suddenly forget to speak their mother tongue when they're in an exam? So covers a small geographical area is what you're reaching for. Oh, it's a local network for local people. No, it's not. It covers a small geographical area. And that's something people get wrong all the time. So make sure that you pick up those first couple of marks on this topic, okay? Which is going to be what is a network, what's good and what's bad about a network, and then talk about the difference between local area networks and wide area networks. It's a network over a local area, a small geographical area. Now let's jump into WANs, or wide area network. The wide area network that we all know is the internet. It's a network of networks, isn't it? It actually connects lots of local area networks together. The difference is that rather than covering a small geographical area, here's your one marker, it covers a large geographical area. Okay, I mean, there are other WANs other than the internet, but the WAN is the internet fundamentally. Now, in this case, the difference is that actually individual companies don't own a wide area network. The infrastructure, and that means the backbone cabling, the routers, all of the devices that are required to move that huge volume of data, these tend to be leased by telecoms companies like BT, like Virgin, and you find actually 2 or 3 companies own all of this hardware, all of this infrastructure, and then other companies. I mean, phone companies, for example, you know, you've got sort of TalkTalk that actually uses, I think they use the Vodafone network. So and they will lease it from Vodafone. Okay. A WAN is more expensive to set up than a local area network, and it connects LANs in different geographical locations. So my advice to you is make sure that you know 2 or 3 of these, so you can talk about what a LAN is, talk about what a WAN is, and talk about the differences. And then suddenly, then things start to get more difficult. Once you've said what a network is, what the pros and what the cons are, and you've talked about the difference between LANs and WANs, then we start to get into more challenging territory because we get into network performance. So if you have a network, when we look at performance, we're talking about how quickly data moves around the network. In other words, once you click on something, how quickly whatever's supposed to happen actually happens. So, for example, you open a file, or you send some data. It involves sending data. So let's talk about network performance. Now, I recommend, and this is it's very catchy, factors that affect network performance. Now, I have a mnemonic which I struggle to say, which I use to do this, and let me try and put this on here for you. Let's do this, and let's go for BELTS. Now, unfortunately, I haven't got around to moving all the data around on this slide to make sense of it, but the B stands for bandwidth, the E stands for error rate, the L stands for latency, and the S stands for sharing, okay, sharing data. Now, there are more of these in the specification, but these 5 will get you all the marks that you need and more. So I'll go through what these 5 actually mean, because you might need to describe them, but you certainly need to understand all of the concepts on this page. Let's start with the one that is often really poorly understood, which is bandwidth. Right, so bandwidth, if you had to define bandwidth, you would say that bandwidth is the rate of data transfer in bits per second carried out by the communication channel. Let's just break that down. If you think about a car, you would talk about a car having a maximum. If we had the Bugatti Veyron, we would say it can do 200 miles per hour. You don't say it can do 200. You don't say it can do 200 miles. For it to make sense, you have to say it does 200 miles per hour. So it's the distance it will travel in that time. For bandwidth, it's exactly the same principle, okay? So it's how much data can be moved across a network in a given time, and it's measured in bits per second. So that's the per second bit, that's the time, and the bits, of course, we know has got to do with the volume of data. All right, so it's the maximum rate of data transfer in a given time, and it's measured in bits per second, megabits per second. Okay. Then the second thing is actually really simple to understand, and this is to do with sharing bandwidth. COVID, if you cast your mind back to COVID, that wonderful time when, as a head of year, I could be a head of year from 25 miles away from the school, which was blissful. At that time, me, my wife, and my 3 kids were at home, and we were all on the internet, as were you. And you were doing online lessons, you were having to look at a teacher talking to you like I am here. Except we found we've got our broadband through Virgin Media, right? So when the 5 of us were here, all trying to access, quite heavy bandwidth demanding applications like Teams and sending video images backwards and forwards, I found that the network performance was poor. And often we would drop calls, things wouldn't work, things wouldn't send. So ultimately, I had to pay more to increase our bandwidth. So sharing bandwidth, we're talking here about the number of users that are sharing a given bandwidth. So in terms of your broadband connection at home, you have a maximum bandwidth, and that is the maximum data transfer speed that what you've paid for will give you. Now, of course, that transfer speed will be faster at 3 o'clock in the morning when no one else on Earth or in the UK is using it, but it's also going to be dictated by how many people are using those communication channels at the same time, or the communication channel you've paid for, your bandwidth, okay? The next bit is, and by the way, if there's anything here you don't understand, just ask a question. That's why I'm here. I'm here to help you. So if I'm saying something you think, I've got no idea what you're talking about, just ask me. I'm hoping you can hear this. I realise I'm miles away from my microphone here. I hope that all makes sense to you, okay? Right, the next part is transmission media. So is the data being carried by a wireless means, or is it being carried by Ethernet cable, or is it being carried by Well, in terms of what we're going to look at later on, we're going to look at sort of whether things are wired and wireless, whether things are Bluetooth, whether you're using Wi-Fi, whether you're using an Ethernet cable, and what types of different media you could use, like fiber optic, for example, which is the Gucci because it's got really fast data transmission speeds. Okay, so the transmission media is going to dictate it. If it's copper cable, it'll be fast. If it's wireless, it'll be slower. If it's fiber optic, it'll be faster. So that will dictate the performance of your network. Okay, this is all to do with how quickly data can move around your network in a given time. Okay, error rate, the next one, is the number of errors. Sometimes there can be data collisions within a network, so data can be lost that way. All right, you can also have hardware that is maybe old or isn't functioning properly. So this might all add up to the error rate. Number of people on the network, that could increase the error rate. So the number of errors in a given time, because obviously the more errors that happen, the slower your transmission speed. Okay, and the last one, if you're a gamer, you will know latency as lag. And if you try playing, for example, Fortnite or Call of Duty online, and you do it on a wireless connection, you will find that you will die more often than someone who's on a wired connection because of that lag. So you press the button you press the trigger to shoot somebody, but actually it's taking longer for that message to get through. So in the meantime, someone else has shot you. Okay, so the time it takes for data to pass from one point to another in a network, that is latency for you. So, like I said, belts. So if after this live stream you think about belts, because belts completely deals with factors that affect network performance. When this happens, it could be a 5-mark question. Given that a grade boundary in paper 1 or paper 2 is 6 or 7 marks, so belts could get you almost an entire grade in one paper and half a grade overall. So it's really worth going away and learning that. Right. So far, what's a network? What are the pros? What are the cons? We've then gone on to look at factors that impact network performance, and we've talked about the difference between a wide area and a local area network. Okay, and we've got a couple of things to say about each of those. Now we jump into, we've got 3 people on. Don't be ashamed to say hello. Now we're looking at the role of computers, and we've got client-server versus peer-to-peer network. These are actually fairly straightforward to understand, especially peer-to-peer, and that's where I'm starting. Peer-to-peer simply means the simplest way that you could possibly make a network. If you imagine at home, you've got your computer, you've got your brother's computer, and you've got your sister's computer. And you want to share files between the 3 of you, you could simply link them together, literally plug them together with a cable, right? And that means that you've then got a simple network. It's not a very useful network, but it does mean that you can share resources. You could share an internet connection, and you can share files. You could share peripheral devices too with that system, okay? So that would be useful. However, it brings its own problems, and we're going to look at that in a bit more detail in a second. The second type of network they're going to ask you about is the client-server model. And I'll spend a bit more time on that one because this is the one they're really interested in. We're now creeping up. We've crept up from grade 1 to grade 2 to grade 3, and we're kind of getting on to grade 4 stuff now in terms of, do you conceptually understand what the difference between them is and what the pros and cons are for each of those types of networks? Right, peer-to-peer. In a peer-to-peer network, peer-to-peer, of course, just to remind you, is one where simply you are linking computers together by either plugging them into each other or by connecting them wirelessly, either or, okay? So in this arrangement, all the devices, all of the nodes, using that word from a few minutes ago, all of the devices are equal, and all devices are directly connected to each other. However, say, for example, you want to look at your mum's or your dad's files, and you've done it and you've connected it in a peer-to-peer way, the files are still stored on the individual devices. So you would need to go and look at the hard drive on their computer, which you can do from your computer, and access it that way. Now, this is typically used in really small businesses. So say, for example, you've started a business and you've had to employ an extra person. In that case, rather than going for a more expensive network, you might just go for this model because that way you can share your stuff more efficiently. But as your company grows and you become more successful, once you get beyond sort of 3-4 people, peer-to-peer starts to peter out really because it's not that useful. It's not efficient. It's not an efficient way of managing a business or managing data. So usually it's used in homes to share files and to connect to printers, etc. Okay. So now we go on and look at the one that they're really going to focus on in the exam. There might be a 4-mark question on this one. Let's think about pros and cons. Oh, sorry, peer-to-peer pros and cons. They are easy to maintain because you simply plug one computer into another. You don't, and if you think back to, I was looking at the negatives of networking, and one of the negatives of networking is that you require technical expertise. Well, you don't require much expertise to plug one computer into another one. You don't need expensive hardware, so it's relatively inexpensive, and you're not reliant on a server. In other words, there's no single point of failure. I mean, going back to the sort of pre-ARC days, when I first started teaching, a computer room just consisted of 30 standalone computers. So if the IT department wanted to update all the computers, somebody who had a look as though they wished they'd chosen a different life would have to come around with one CD and put it into 30 different computers and click next. Oh, I see my image has disappeared there. Let me see if I can reboot it. Oh, I'm back in town. Hello, can you pick me up? No, it's died again. Right, I'm going to just bear with me 1 second while I sort this out. It said the battery was at 100%, and it lied. Let's see if that works any better. Hello, I'm back in town. Hello, here we are. Right, so they're easy to maintain, no requirement for technical expertise, and no requirement for expensive hardware. And you're not reliant on a server. However, the problem is there's no centralized management. So that means updates have got to be installed individually. Hence my story about a 30 PC computer room where some poor soul's got to go around with a copy of Windows 95 and update every single computer. And we had at that time, I think, we had 120 computers in school. So they had to allocate somebody 2 or 3 weeks to go around and do all of these because it was just soul destroying. You can't make backups. It's very complicated making backups when you've got a peer-to-peer network, and copying between different nodes, different computers, is a pain in the neck. You end up creating duplicates. Sometimes you delete things where you haven't got duplicates. It's just really difficult to manage and organize. And also, peer devices are less reliable. You're more likely to lose data, okay? And also, it's much slower in terms of moving data from A to B. All right, so let's now have a look at a client-server model. This is the one they're more likely to ask you more about and to give you more marks for getting right. So first of all, in the client-server model, you've got 2 different types of computers. You've got the client and you've got the server, okay? Now, a server is a powerful, dedicated computer. That doesn't mean it's dedicated because it works hard. It means it's dedicated to a particular task. So, for example, you might have a print server, which is responsible just for printing, for doing all the printing for the entire school. You might have a file server. Well, you will have a file server. And that file server is responsible for holding and managing all of the student and teacher and back office staff's files that they create, okay? And in fact, what tends to happen is it can be virtualized, so all these servers can actually run on the same physical piece of hardware. So in the case of a client-server model, all the files are centrally stored on the server, not on the individual devices. So just think about that for a second. When you're sat in your computer room at school, there'll be a switch somewhere in your computer rooms, the thing that flashes a great deal, that's got about 30 inputs going into it, 30 ports. All of the data that when you open a file, It's not stored on your individual computer, on the computer you're working on. It's stored in the server room. So it sends a request. So let's say you try and open the Word document or the PowerPoint you were working on last lesson. It will send a request to the to the server. So you, the client, sitting in school, will send a request to the server. And the server will then process that request and respond accordingly. So that is how it works in a client-server model. There are huge advantages to doing things in this way. For example, the server is able to store all the user profiles and passwords. So I would have a different user profile to you because I've got teacher access. So therefore, I'll be able to have certain, and this is down here, in terms of all the user profiles. So my user profile will be different from yours because I'm able to access different things to you. And obviously the passwords, that's quite a big job to have all the passwords for 1,000, however many students you've got in your school. You can also, in the client-server model, use access levels to deny certain users access to particular data and files. So for example, the shared area where you can access files in school, I can write to it, but you can only read from it. I'm able to access a staff area. You can't access it because you don't need to. I'm not able to access the payroll system because if I could see what the head teacher earns and I could probably try and steal some money. I don't know how successful I'd be, but obviously I'm limited to my job function and to what I need to do. So we've talked about file servers, we've talked about print servers. Think about what a print server does. A print server is a dedicated machine, or it might all work on the same machine, which simply manages the print queue for the entire school. So somebody in the art department printing off a Photoshop document that they've created, or somebody in the DT department printing off something from CAD software they're running, the printer queue is going to be entirely managed about where it's printed, the order in which it's printed, etc., etc. Okay, so that's a print server. We've also got a web server. I want to pause on web servers for a second because they might ask you about this in a different part of the paper. And you need to understand that web servers are where websites are hosted. So when you access a website, that website is going to be stored on a web server, because a website is simply a bunch of HTML documents, hypertext markup language documents, similar, the same sort of idea as Word documents, and all of the images, all of the audio files, etc., the video files. A web page is simply a collection of these, and it's written in HTML, so a web server would hold all of those files. All right, now we go on to the pros and cons of client-server networks. They will ask you something about this in the exam. The benefit is that you can keep track of centrally stored files really easily. You can perform backups. We at school do a backup every day. Your school will do exactly the same thing. They run a backup. They'd probably use, they do use magnetic tape to run the backup because it can hold a huge amount of data, but it's quite slow. But it's got, 12 hours of downtime to back it up, so it can be done really easy. I mean, it runs to several terabytes. It's also, thinking back to the example I gave you earlier about the poor woman who had to go around and install Windows 95 on 80 machines over a 2 or 3 week period, you can actually install and update software in one go and send it out to all of the computers. You can also manage network security centrally. Things like anti-malware, access levels, so you can manage all of that centrally using your server. And the servers are reliable, apart from when they're not, and they're always on. Issues, they are expensive. You need someone who knows what they're doing to manage them, and people who know what they're doing cost you more. There's a single point of failure. If the server goes down, teachers are scrabbling around trying to think what they can do without PowerPoints and sobbing gently to themselves. But also, if the server's overloaded, if too many clients are using it at once, it can reduce the network performance. So we've covered quite a lot of ground here in terms of what's a network, what are the pros and cons, then looking at the different types of networks, local area networks, wide area networks. Then we looked at belts, didn't we, about the factors that impact network performance. We then went on to look at the two different types of network, which is peer-to-peer and client-server. So that brings us up to date with where we are. We've got 5 in, so please do say hello. Right, let's look at network hardware. You need to have an understanding of a few pieces of network hardware, and it's these 5 here. WAPs, routers, switches, NICs, and transmission media. So I'll go into what these are, and you need to focus on what they are, what they do, and what their benefits and weaknesses are. Okay, so you can be able. Really, the main thing is defining what these things actually do. You're not going to need pros and cons. You need to define what these bits of hardware actually do. So let's start. And by the way, I apologise for the woefully tedious image here, but most of these devices are just boxes. I thought this time I'd find a white one, just because most of them are black. So here is a white box. This is called a wireless access point. So it is, it's a piece of hardware. It is connected to a network, and this is what it does. It allows wireless capable devices, in other words, devices that are able to connect wirelessly, to connect to wired networks. So for example, hi, who's behind the door? I had a feeling it was you. I can rely on you. It is me having a session with you again. I'm really pleased you're here. I realised I hadn't actually put my blinking slides on, so hopefully the previous bit made sense to you, but that was kind of early doors. Listen, any questions, just let me know. I don't think you do, because you know your stuff, but any queries, just let me know, okay? Right. So here's the thing. Say, for example, you have got a computer and you're accessing the school you're accessing your home networked wirelessly. Your router, which is the box with all the flashing lights in your lounge or wherever you've got it, that also incorporates a wireless access point, because your router allows a wireless capable device, i.e. your phone, to connect to the wired networks. The internet, for example, and that happens through your router, but your router will contain a wireless access point. Now, connections made through a couple of standards. I'm not going to focus too much on Wi-Fi and Bluetooth today, because I'm going to cover that next week, okay? And it's also known as a hotspot. There we go, boom. So that one's done. And really, let's go back to here. What you need to know is this. That is your mark there, okay? If they ask you about it, that's where they're going to ask you. Next, we've got the router. Warning, 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 right? When it comes to routers, OCR love a router question. And I kind of get it, because routers are absolutely central to networks, because they do so much of the heavy lifting. Here's what a router does, and there's one mark each for these. A router receives packets, because in a network, data is split up into small chunks called packets. The router also forwards data packets, one mark there within a network. It also transmits packets to different networks. There's a third mark. The final thing is there's lots more. It can read the final destinations. The router's quite an important piece of kit here. It'll read where the packet's supposed to go. It'll work out the most efficient path. So, for example, if you are sending data from here to Hong Kong, for example, it will go through, half a dozen routers. And so these routers are identifying the quickest route to send your data. A router also assigns IP addresses, which are the Internet Protocol addresses, and it converts packets from one protocol to another. You don't need to be able to produce all of these, but you do need to be able to produce maybe 4 or 5 of them, 4 of them, which is, to be fair, most of them. But they could theoretically ask you up to a 6-mark question on a router. A router is probably the single most important piece of hardware that you're going to sort of consider within a network, because they do so much heavy lifting. So it's really worth going away and perhaps thinking about a way of effectively learning those. But with packets, receive, forward, and transmit, there's 3 marks for you right there. I've put this in here just so you know that routers are both wired and wireless. You don't need to know anything on here other than the fact that the benefit of a wireless router is that it's convenient because you can move around. The drawback is the data transmission speeds are slower with a wireless router than they are with a wired one. So it's pros and cons, really. Now we come on to a switch. Just two things for a switch, really. I mean, a switch is a fairly simple piece of kit. I use a switch at home, and it's purely because I haven't got enough Ethernet ports. These guys, by the way, here are the Ethernet ports. I'm sure, well, I know that you know it. I don't know why I'm telling you. Let's go to here. Whoop, back to here. There we go. These are the Ethernet ports here, and I think my router's got 4 Ethernet ports, and I actually need about 7 Ethernet cables. So I simply bought this as a kind of extension for it. But what does it do? It switches connections between ports and devices. So hence, when I've got my Sonos plugged into it, that's one of my devices, okay? And it also makes full use of bandwidth. So two things you want to know. It makes full use of bandwidth, and there are no data collisions using a port, which is when data is traveling. Often it's when data is traveling at different directions through a cable. The data packets collide with each other and it's lost. So hence it's an error, which is our E in belts for error rate. Okay. Now we come on to the NIC, which is a network interface card. So this guy here is plugged into the motherboard of your computer using these. This is what plugs directly into your motherboard. This here is your Ethernet port. So you plug in your Ethernet cable. This is telling you whether there's data running through it. This is telling you how quickly it's running through it. And then the wireless part, I think the wireless transmitter's here. I can't really see on this one. So this one is both a wired and a wireless connection, okay? Both wired and wireless way of sending data. Now, it usually consists, it's usually used with copper cable, and we'll get to unshielded twisted pairs later on, and it's sometimes integrated into the motherboard device, particularly in lower cost machines, where it can actually be built in, because it's less expensive that way. You just produce one motherboard that's got a fairly sort of low rent NIC incorporated into it, okay? And what do? They connect computers to networks. So you use the network interface card to connect to a wired or a wireless network. You would plug this into your router, and therefore you'd have access to the wide area network, i.e. the internet, okay? Which covers a large geographical area. Excellent. Let's keep going. We are 37 minutes in. I'm going to look at transmission media. There's not going to be much time for questions today for doing the quizzing, because this is quite a sort of there's a lot of material in this topic. It's the one that people tend to do more badly on. Transmission media. So this is a CAT cable. You recognise this little tab here that you've got to click in there and then press this guy down to remove it. So this is an Ethernet cable, and this uses the Ethernet protocol, and this is how you sort of pretty much plug this into your router and then gain access to the internet. But the CAT stands for category, and I think now we're up to 8 or 9, maybe even 10. And so they bring out a new one which just supports slightly faster data transfers. So this is a protocol they're always looking to improve. So let's think really quickly about the local area network and using copper cable. And by the way, this guy here inside this CAT cable, inside this housing here is copper cable. And we'll come onto that in a bit more detail in a second. So when you use copper cable, and there's a pretty faded version of copper there, you can see the colour of it, copper supports fast data transmissions. I wish it wouldn't keep doing this, it's driving me mad. It supports fast data transmissions. Well, that's really useful because people want fast data transmissions. It's also extremely reliable. You get minimal interference, and it's thin and flexible. It's also really easy to install because it's so malleable. So you can almost turn copper cable through a right angle, which makes it ideal for laying in schools and offices and homes, because you can put it through walls. You can turn left, you can turn right. It's very simple to work with. Okay, unlike fibre optic cable, which is much harder to bend. It's not as malleable. Right. By the way, this I'm telling you because if you don't know it, this topic's really hard to understand. They're not going to ask you a huge amount about copper cable in the exam, but I think that in order to be able to actually perform well, having an understanding of what sits behind it is really important. So this is what is going on here inside your Ethernet cable. And notice you've got 4 pairs. One will go away. It's done it again. I've got to go through the whole rigmarole each time. 1, 2, 3, 4. 4 pairs of copper wire. And these 4 pairs involve 2 cables just here twisted round each other because that reduces internal interference, which means the signal gets carried as efficiently and quickly as possible. Then we've got fibre optic cable. Fibre optic cable is the Gucci solution for transmission media. This is what it looks like. You've got, okay, let's go to the next one because I've got a bit more detail there. It's a pretty picture. You've got the outer jacket. You've then got the coating here. This gives it some strength, this yellow bit here. You've got some cladding and you've got the core, okay? So really it's all about this bit here and everything else just protects it. So fibre optic cable, how does it work? It works by transmitting pulses of light across glass fibres. And because of that internal reflection, there is no or practically no data loss. With copper cable, if you're sending data along copper cables over long distances, every so often you have to put in a repeater, which actually builds the signal back up again, because the signal drops over time and over distance, on a copper cable. Not the case with fibre optic, which is why it's fibre optic cable that runs under the Atlantic carrying broadband, carrying internet feeds, okay? So no interference. Also, it can deal with the most disgusting conditions: underwater, freezing cold, really, really hot. It's brilliant. It's what you would like to have because it's so super fast, which is what this is all about. It is high performance. The problem is it's really costly. And if you had to lay this in a school, it'd be a pain in the neck because it's not bendy, it's not malleable. So you'd have to work out how you're going to actually going to lay it. So, for example, in all computers rooms in schools, every room consists of 4 corners, doesn't it? And if you've got the trunking, which holds the cable, you really couldn't do this with fibre optic because you just couldn't bend it in the same way as you can copper. So it wouldn't actually be a great solution for the reason that it's just not malleable enough. Good. Right, let's push on. The internet. Now, the internet, they will ask you a couple of fairly simple questions about what the internet is. And what you need to say is that it is a network of networks. And it is the largest WAN. That's it. It's the largest WAN, okay? And information, and people often get a bit confused about this, is that if you think about a train, okay, and people talk about the internet and the World Wide Web, the internet is the train, the World Wide Web, email, all the rest of it, those are the passengers. So the internet is the infrastructure, while the World Wide Web is what you do on that infrastructure. And it's based around the TCP IP protocol, which we'll cover next week. This again, they always ask this. Websites are hosted on web servers, and it's accessed through that protocol, which I won't go into now because I'm covering that next week. What I do want to say, though, is that URLs, which stands for Uniform Resource Locators, are the individual addresses that are used to access web servers' resources, i.e. web pages. So bbc.co.uk/news is an example of a URL, a Uniform Resource Locator, and they will ask about that. Students need to learn the story of accessing web pages. Right, which is this? The domain name system. So here is the story. The domain name system is like the phone book of the internet. So the domain name server, it's a database of domain names. Now, an example of a domain name is Nike.com, okay? An example of a URL is Nike.com/trainers, okay? So But underneath Nike.com, Nike.com is something that's been created to make it easier for us to use the internet. Because if we had to know that the Nike address was 192.158.138, it would be a nightmare. If we had to know the IP address for each website, it would be impossible to use. And because that's the case, they've created this domain name system, which means that we've got these beautiful domain names that are easy to remember, but sitting behind it, hidden, abstracted from us, are these IP addresses. And there's an example of an IP address. And can you see it's 1, 2, 3, 4 sets of numbers between 0 and 256 that are separated by full stops. Okay? So humans access information through domain names and URLs, okay? So hidden behind that is the actual IP address, and this is where DNS comes into it. I'm going to leave that for a second, and I'm going to come back to here. So when you type in www.nike.com, what happens is that the DNS server, your browser, pings that request to the DNS server, and the DNS server converts it to the IP address. And there's an example of an IP address there. That gets pinged back to your browser, and then your browser forms a connection directly with that IP address, okay? So that's how you're able to access internet resources. DNS server is regularly updated, don't worry about that. Domain name service is multiple domain name servers. So it's a really clever system, actually, and it's a sort of decentralized system, a bit like Bitcoin, in the way that, say, for example, you're going on a holiday to Mumbai in India, and you want to access a hotel in the locale where you're staying. You might type in the URL for that, but actually it doesn't recognize it. Your local domain name server doesn't recognize it, okay? Because I've got domain name system. This is what the overall system's called. But the domain name system consists of servers which contain basically tables. It's a database, a lookup table, which will have Nike.com, and then next to it have the IP address. So it's a phone book, okay? So while your local one in East Grinstead might not have the actual IP address for that restaurant, it will look at it, the domain name server will look at it and go, well, no, I don't have that, but that looks like an Indian address. So I'll ping that to the DNS in India. It'll do that, and then it'll find it and send that and send the IP address back to your computer, and then your browser can then send that will then open a direct connection with that IP address. And that's kind of what I'm talking about here, okay? If domain name isn't found at one DNS, then another can be used. It's known as the domain name service. It's a bit confusing when you've got domain name service, DNS, domain name server, DNS, and domain name system, DNS. But there we go. That's the story. If you can rehearse that story so you genuinely know what happens between typing in a URL and that web page loading on your browser, that is often an 8-mark question. So bear that in mind. In your mock, they did a gap fill on that, so they won't necessarily do a gap fill again. But this is a very good way of establishing, is this student a grade 8 or grade 9 student, grade 7, grade 8, grade 9 student, because the concepts there are quite tricky. So that's something that's really worth being really super clear on what a URL is, what an IP address, what DNS is, and how that story actually unfolds, okay? Right, now we get to hosting. Cloud storage, software, websites, etc., they all need to be hosted. They need to be stored somewhere. Businesses often store their data on servers. And we've already talked about file servers that are used for housing people's files. We talked about print servers that can organize the print queue. And websites, I think for the third time today, are hosted on web servers. And we know that websites have got a domain name, Nike.com, for example. And the domain name, so if you were to set up a website, you would go and purchase a domain name. You would then have to register that domain name with the domain name server, the DNS. Otherwise, people can't find you. And you've got to point that domain name server to wherever you're hosting your website, okay? and then your domain name points to the IP address where the website's hosted. So that's really important. That's how hosting actually works. When you visit a website, and I've kind of talked about this already, when you visit a website, this is how it works. So you enter the URL, and let's go up to here. You enter the URL, so for example, gcse.org.index from a web client, i.e. a browser like Safari, Edge, Chrome, Firefox, Opera, whatever you're using. And that domain name is looked up on the DNS, unless you already have it in your cache memory, which you probably will do if it's one that you visit regularly, okay? Then the public IP address of the website is found in the DNS. The website uses the IP address to request the web page from the server, and it opens up. I've kind of already covered that. So that's the story put another way. Yeah, cloud storage. They'll ask you a question about cloud storage because they want to know, do you understand that cloud storage means storing data online at a remote location and you access it via the internet? They love to do a question on cloud storage, and they want you to evidence that you understand that one of the drawbacks of cloud storage is that you need the internet to access it, but there are several pros of using cloud storage as well. And also increasingly now, you're able to actually execute software from the cloud as well as store software in the cloud, because the speeds have increased so much. The pros of cloud storage, as long as you can access it from any device, it's easy to increase storage. So rather than having to buy a new hard drive to increase your storage, you can simply pay more for your subscription and you get access to more storage. You don't need to pay for the expensive hardware. You've not got to pay for staff to manage it or manage it yourself. And the host will provide backup security, and the software will be updated automatically. So all of those things are really useful. Negatively, this is the key one, in order to access the cloud, you have to have an internet connection. Being dependent on the host for security and backups could be a good thing or a bad thing, depending upon how good your hosts are at doing their job. There's a vulnerability to hackers with storing anything online, and especially if you host your data overseas where it's cheaper, there's a lack of clarity over ownership of data, and also questions about data regulations as well, GDPR in the UK. And also the subscriptions might become prohibitively expensive. So you've got enough there to answer any question on servers. And do you know what? I've talked about these three. About a web server which hosts websites and it handles requests for static information, HTML pages. You've got a mail server, which is used to send and receive email addresses, and you've got a file server for centrally storing and managing files. Right, last thing I'm going to cover today, I think. So, yeah, I'm going to carry on for 8 minutes and do topologies. Who's behind the door? You're still there. You're very brave. Right, topologies. Topologies are the way in which a network is structured or put together in simple terms. So let's look first of all at the star topology. You need to know about two topologies. You might need to draw a diagram. They like making you draw a diagram, or they'll draw a diagram and leave certain things out, or they'll ask you to they'll describe a topology and then ask you to draw a diagram with, X number of PCs and X number of computers and X printers and so on, okay? So within the star topology, all devices are connected to a switch, and that is the sort of big rectangular box you've got in your computer science room, which has got lots of flashing lights and 30 odd cables going into 30 ports, okay? So the switch, what does it do? It receives data from each device and it sends data to recipient device. So that switch is really a means by which data is able to be sent from the client to the server and from the server to the client. However, one of the issues, one of the facts is that data can't travel directly between devices. It has to go through the switch. So it's like the portal through which everything has to travel. Now, the advantages are that the switch, you get fewer data collisions. Okay, we've talked about this several times today, which means faster transmission, 2 marks there, because the switch only sends data to the intended devices, which improves security, okay? Adding a new node is really easy. You just plug it in as long as you've got enough nodes, and there's no disruption to the network. However, if the switch fails, no one gets any computing, so that's problematic. And also, you do need a lot of cabling, all right? And sometimes I see the network, I see the IT crew crawling around trying to work out which cable it is that's failed, because cables do fail. Surprisingly often, actually. All right, now the last thing we're going to cover today is the mesh topology. And by the way, the internet, the wide area network, is a partial mesh. So you need to know that this is the way it works. In a mesh network, the devices are connected directly to each other. There's no switch like there is in the star network. And the data can flow in any direction. Now, in the case of a full mesh network, every node is connected to every node, and the data travels directly to each node. In a partial mesh, well, you've guessed it, every computer is not connected to every node, and so there are data hops from one node to another. And obviously a partial mesh is less expensive because it requires less cabling. So pros and cons. So in the case of a mesh network, if a connection is lost to one node, an alternative route can be used, okay? Mesh Wi-Fi is cheaper than traditional large Wi-Fi networks, and it runs quickly because packets don't have to go via a switch. However, if you're using cables, it's expensive. If you're using wireless, it's less expensive. But you do need security to prevent unauthorized nodes being added. And all nodes in the network need to be capable of routing. All right. I'm thinking now about possible scenarios. Now, this is something they haven't yet done. If I'm going to be honest with you, I'm pretty dreadful at predicting questions. But I think they might give you a scenario where they say, for example, Alicia runs an internet cafe. What sort of network would you suggest? What sort of transmission media would you suggest? Would you go for wired or wireless? I'm going to cover wired and wireless next week, by the way, okay? And so in that case, you would weigh it up and think, well, it's a cafe, so it's not going to be wired connection because that would mean people tripping over wires and suing her for breaking their necks. So it's got to be wireless because that's more convenient. The drawback being that you don't quite get the same data transmission speeds with wireless, but you go for that because it's more convenient, and also it supports bring your own devices because it's more flexible because you don't have to have a set number of users. You want to be able to have 2 customers in the coffee shop as well as 200 and sell 200 coffees at £8 a pop. So also thinking about things like security of data, the fact that wireless is less secure, thinking about the cost, the initial setup cost, buying a switch, very expensive, a simple wireless network, far less expensive. How is it that people would be working? So for example, compare the cafe example I just gave you with Sanjeev has an animation company where he's got 8 animators who work at their desks. They work at the same desks every day, and they need to produce animations that require an incredibly high bandwidth. What would you suggest? And in that case, you're thinking, well, if they're going to stay in the same place, that means that they don't need wireless. If it requires high bandwidth, huge amounts of data, in the case of animation, it would be huge amounts of data needing to be moved across the network, then you've got to go for wired. You might even think about, what transmission media would you think about? Well, maybe this would be a case for not using copper, but actually going for fiber optic instead, thinking about the different topology that you might want to use. So these are the scenarios that they haven't done this yet, but there is the possibility of them actually asking a question like that for you in the exam, okay? And thinking about interference, that's something else that you could talk about. Also, thinking about a wired network. A wired network means that people need to have Ethernet ports on their network interface cards for their devices, okay? But that would mean that you couldn't connect your phone to a wired network. Connecting a mobile device to a wireless network is much easier. So these are the sorts of different areas you might need to focus on when it comes to being given a scenario and talking about what it is you're going to do. Who's behind the door? We have made it. It is past. I've been going for an hour. I'm going to stop. I hope that was really useful for you. Out of interest, was there anything new in today's... because you've always said, yeah, it's nice to recap, but nothing much new in there. Do you feel as confident? That's really kind of you. I'm really glad you enjoyed it. I'm really glad you enjoyed it. Well, I'll see you at the same time next week, and we're going to pick up on networks, on protocols and layers next time, which is also quite a technical topic. I think it's one to be useful for you because you strike me as someone aiming for the 7 to 9 category. Perfect. All right, I'll see you next week. Have a great week, and thanks for being there. Take care. Bye-bye. Bye-bye.